People take question number 13, part B, question number 4 in the paper, vector question. It's part A. Given that relative to a fixed point O, the position vectors of 2 points A and B are simple A vector and simple B vector respectively. Right? Okay. This way, A position vector is simple A. Here O, here B position vector of simple B. Right? The points C and D are situated on OB and OA. Point C, OB, of CB 5:2, and D lies on OA, ODDA 3:2. Like this. Lines AC and BD. AC and BD intersect at T. Show that OE we can write like this. OE we can write like this, huh? Right. Right now, ask him to write OE, this vector. Okay. Right. Now, this OE you can write this way. OE vector, we can write people OA vector plus AE vector, right? See. Right. Now this OE vector, we can write OA vector is simple A to E vector, you can write people as a fraction of AC vector. That means AC vector, A to C vector, when we divide by something, we get AE vector. That number I write as lambda. Okay. Now we can write this AC vector A plus lambda times AC vector, you can write A O plus OC. Right? Right. Now OE vector A plus lambda times AO vector is minus A, and this OC vector you can write, okay, OC is CB given as 5:2, no? The ratio. This one correct. I'll take here OC vector. That OC vector you can write as a fraction of OB vector. It is vector B here. If we divide by sum of these two ratios 7 and multiply by 5. This way. You can write this OC vector. Okay. Then OE vector we get A plus lambda times 5 by 7 vector B minus C. And now this OE we can take as the question asking to obtain another expression for OE. As that OE you can take this. The asking answer we can take in the second. But asking answer contains lambda. So therefore I shall take this in this case this lambda as mu, right? I'll take this as mu, right now. This way. This is our second required answer for OE. At first answer for OE we can take like this. We can go this path OB plus BE to get OE, right? Secondly, you can write OE OB plus BE. Then OE vector is equal to OB simple B vector, right? And BE vector you can write as a certain part of BD lambda times BD. Now OE vector is equal to simple B vector plus lambda times this BD vector you can write as BO plus OD. Right? Then OE vector simple B vector plus lambda times BO vector is minus B. OD vector you can write dividing this A vector by 5 and multiplied by 3. A vector should be divided by 5 multiplied by 3. Then OE vector we can write vector B plus lambda times 3 by 5A minus B. Correct, no? This is the first answer. Now obtain another expression for OE that we already obtained here. Hence find the Poisson vector of E in terms of A and B. Then what we do is this. To find the Poisson vector of E, that means OE vector, no? We should either know this mu or lambda. Now our next purpose is to find this lambda or mu. For that we can equate this expression for OE with this, right? Now we can take the next one like this. A plus mu times 5 by 7 B minus A equals B plus lambda times 3 by 5 A minus vector B. Now we can equate the coefficients of A on both sides. Here coefficient 1, here minus mu, and here 3 lambda by 5, number 1. And B coefficients, when we equate, here 5 mu by 7, right hand side here 1, when we remove the bracket here minus lambda, number 2. Now, another simple thing you have to do, what? By solving these two equations, find lambda and mu, only one lambda, enough, lambda or mu. Getting lambda or mu, right? If you get lambda, put that here, then we get OE. If you get mu, put that here, then you get OE. Okay? I think by solving these two simultaneous equations, first part you can easily do, right? Do that part, right? I leave that part. Okay. Right now, let's find the Poisson vector of E in terms of A and B. Right. And then the final answer, yeah, I think you can do that. Okay. Now take its part B. Take part B, right? Part B. Relative to a point O, the position vectors of 3 points A, B, C are A, B, C respectively. Right. Take like this. Okay. Here A, here B, here C. Right. Position vector of this is simple A, this is simple B, this is simple C. The point P is on BC. BC here, right? And given that PC, point P is on BC, given that PC, P here, PC vector is equal to 1 upon 10 BC vector. 1 over 10 BC vector. Right. Find our P vector. Find OP vector in terms of A and B. OP vector asking to find in terms of A and B. This vector OP. Right. The position vector of capital A point is simple A. This is simple B. This is simple C. This is the diagram. Right. I now ask him to find the vector OP in terms of A and B. Right. This way we can write this OP vector. OP vector we can write OC plus CP. OC plus CP. Right. Then OP vector we can write OC vector is simple C vector. CP vector we can write minus PC. But PC vector we have 1 upon 10 BC. Plus and minus PC 1 upon 10 BC. C minus 1 upon 10 BC vector is C minus B. Then simplify this. Take 1 upon 10 out. Here 10C minus C is 9C plus B. People, this is the required answer. Asking to write OP vector in terms of A and B. No, that should be C and B. Yeah? That should be corrected as C and B. Okay. This is the OP vector 1 upon 10 9C plus B. Next one asking this way. Part 2. If it is given that AP and BC are perpendicular. AP and BC are perpendicular. AP. AP vector is really this vector, no? From A to A. This vector is AP vector. AP vector and BC vector are perpendicular. So that this answer, right? AP vector and BC vector perpendicular mean AP vector perpendicular to BC vector mean, you know, when two vectors are perpendicular, you know, dot product is 0. The dot product of the vectors is 0. AP dot BC should be 0. Right. AP vector, you know how to write. AP vector you can write quotient vector of P minus quotient vector of A. Right? BC vector quotient vector of C minus quotient vector of B. This is quotient vector of P, that is OP, minus quotient vector of A means OA. Dot quotient vector of C is simple C minus that of B is simple B, should be equal to 0. Right? Now, ask me to show this answer. Yeah. Quotient vector of OP, I can write by using the dot product this way. Use the distributive law. OP dot this. OP vector dot C minus D. Where I use the distributive law minus OA vector dot C minus D should be equal to 0. Now, you can substitute for this OP vector. OP vector, we found this answer, put that here, 1 upon 10, 9C plus B dot C minus D vector. Take this to right hand side, that will be plus OA vector is simple A now. A dot C minus B. Yeah, in the question, the answer here is 9 printed as A, that should be corrected as 9. You see, you can take that. Now, next one asking, hence, if OA, OB, and OC are mutually perpendicular. OA, OB, and OC are mutually perpendicular. Mutually perpendicular mean what, people? If you take any two of them at a time, that two perpendicular. That means A and B perpendicular, A and C perpendicular, and B and C perpendicular. Right? That means vector OA, OB, OC are mutually perpendicular mean, right? OA, OB, OC mutually perpendicular. Mutually perpendicular mean what? A dot B 0. Why? A and B perpendicular. Then dot product 0. A dot C also 0. And B dot C 0. Right? Now, we can remove this bracket. You've seen the result above. Yeah. You can expand this now. 1 upon 10 9C plus vector B dot C minus B A dot C minus B. Right. Now keep 1 upon 10 here, open a bracket. Here we get 9C 9 times C dot C minus 9 times C dot B. This and this we take dot product, this and this we take dot product. Next one, B dot C minus B dot B. Right hand side, A dot C minus A dot B. This C we get. You know B dot C, this 0, this also 0. A dot C, A dot B also 0, no? Then the right hand side will be 0. Right. Then what do you get there? Yes, then we get what? This is 0. This also 0. Then we get 1 upon 10, 9 times C dot C minus B dot B will be equal to 0. Okay, no? Then yes, part should be 0. 9 times C dot C minus B dot B will be equal to 0. This one you can write 3C plus B vector dot 3C minus B vector. Why? When you use the distributive law here, 3 and 3, 9, C dot C, this is coming. This and this when you take 3, C dot B. C dot B is 0. We know that. C dot B means C dot C, no? And this also when you take the product, 0. This and this when you take the product, B dot B, this is coming. Correct, no? Then this one you can write this way. That is how we take it out. Right. Question number 5 next. Question number 5 says, in the triangle ABCD, AB is 4 meters, BC is 3 meters. Some forces given. Right now, calculate this now. Yeah, ABCD in the triangle, a rectangle, ABCD, right? 5. rectangle. Right. See here. B, C, D. AB is 4 meters. This BC 3 meters. The 90. Process of magnitudes 873. Acting alone. AB side it is 8. BC side 7. CD 3. DA 2. AC 8. C8 and DB 7. Right. Let this angle be theta. Yeah. Find horizontal and vertical components of the resultant force R. If you take this angle as theta, side this side 4, this side 3, therefore this AC side is 5, right? Then the sine theta and cos theta we can write. Sine theta going to be 3 over 5, cos theta 4 over 5. If this angle theta is also theta because this length is 4, 3, therefore again this is 5. Now we have to resolve horizontally. Take x 8 cos theta is 4 by 5 and left hand side 3 minus 7 cos theta 7 into 4 by 5. Then here we get x here 32, here 28, 60. 60 divided by 5 means 12. 12 minus 3 is 9. 9 plus 8 is 17. X is 17. Okay. Right. We can take resolving up y. 7 here and minus 2. 8 sine theta plus sine theta is 3 by 5. 8 sine theta minus 7 sine theta. 3 by 5. Correct, no? Only 4 forces there we have. Yeah, then there we can simplify. This is 5. Here 3 by 5, no? Then this is 28 by 5. Upwards. Now, next one asking, hence find the distance from A to the point, the line of action of the resultant cuts AB. Right, now the resultant, suppose cuts AB somewhere here. This is the resultant R. Its horizontal and vertical components only just now we found Y and X this way. Now we take for the system moments around A. We take the moments around A in anticlockwise. Then this 7, 3 will give anticlockwise moment, whereas this 7 gives clockwise moment, no? 7 into 4, the distance 3 into this distance is 3. And this 7 gives what people? Clockwise moment. This force 7 we resolve at the point D. Then D cos theta, 7 cos theta, 7 sin theta. 7 sin theta component passes through A, no moment. 7 cos theta gives clockwise, no? 7 cos theta into 3, therefore it is minus 7 cos theta. 7 cos theta is 4 by 5. 7 cos theta into this 3 should be equal to the moment made by this R. R also I have resolved it to two components x and y. X passes through A, no moment. Y, this length will take as D. Y into D. Y means 28 upon 5 into D. By solving, you can take this D. You get for this D 101 divided by 28 or something coming, no? Yeah. D is 101 divided by 28. That comes in meters, no? Comes in meters. Right. Now, given this way, now a couple of moment, 9 Newton meters, in the sense ABCD is added to the system. So that the new line of action of the resultant cuts the side AB at a distance 2 meters from A. Now, this 1, 2, 3, 4, 5, 6. The 6 forces together give us one resultant force like this. Okay. Then I can ignore all these 6 forces. Instead of that 6 forces, this single force I can consider. Okay. Yeah. So now, if I draw that diagram here, this is that single force acting this distance 101 over D. 28, no? That is D. Then this horizontal vertical components we know y is. So this only 9 Newton meters A, B, C, D anticlockwise, right? Moment is added. Okay. Couple of A, B, C, D. Then you know when a couple is added to a single force, we know that single force displaces, right? So now this final effect is this couple plus this single force together brings this single force to another point of action, but still the size of the resultant and direction being the same. Right? I'll take it like this. Another different point. You can see now. Then this length, suppose L. This L only asking. Then you know this system, single force plus the couple together use this. Therefore, this system and this system are two equivalent system of forces. Therefore, around any point on the system of forces, the moment should be equal. Then I can take a moment around A, okay, anti-clockwise. When you take a moment around A for the both systems, the new length simple L you can find. Okay. Now you can write the moment made by this y. Y we know, take a moment around A anti-clockwise. Y 28 by 5 into 101 over 28. Okay, the moment of y plus 9 should be equal to here the moment. Here y only gives the moment y into L. Y means 28 by 5 into 8. Right. Then when you simplify this, you should get this answer. 28 and 28 you can cancel down. Then here we get 101. This is 45 by 5, 28 L, no? Okay. Right. Then do we get this answer? Right. Take this answer. Should get this answer. And now here, according to our calculation, this answer is correct. Okay. According to our calculation, this answer is correct. Yeah. In the question we are given the couple is added in the sense ABCD. ABCD means this way, anti-clockwise. But here, this answer for this L exactly you get as 2 when this couple has a sense clockwise 9. But given it is ABCD. But this calculation is done taking that 9 clockwise. Therefore, our answer is correct. Take this answer here. This is correct. Right. Our answer is correct. Whatever you get there, that is correct. This 9 Newton meter couple is added to the system. Question says in the sense ABCD. Correctly, we took that. But once we take that clockwise 9 only, the answer coming as 2. But this is correct. Nah? There's a mistake in the question. Right. Okay. Yeah. Okay. Come to part B. Yes, you are given state Lami's theorem. Lami's theorem is what? When there are three forces acting on an object, right? This way, alpha, beta, this is gamma. Then by Lami's theorem, what do you say? P divided by sin alpha equals Q divided by sin beta equals R divided by sin gamma. Is the Lami's theorem. Write that. Yeah, next one. Right. ABCD is a light inextensible string. The string is tied to two fixed points A and D in the same horizontal level, and two particles of weights W1 and W2 are hanged at B and C respectively. At the position of equilibrium, B lies above C, and the parts of the strings AB, BC, and CD make the angles alpha, beta, gamma, respectively with vertical. Show that this answer. Yeah. This is the Lami's theorem. Spectral diagram here now. Yeah, AB, CD. one weight here, other weight here. Right. A, B, C, D here. Here weight W1, here W2. When we construct verticals here, at this string, suppose tension T1, here also T1, this is T2, here T2, here T3, this is T3. Right, now we are given this angle as alpha, right? This angle is beta, this angle as gamma. Then we can apply Lamy's theorem. Right, apply Lamy's theorem here, find T2, and here again find T2. Then that T2 expressions we can equate. Thereby we can take this answer. Right. That's how we take this answer. Right. So then here we need this angle. This angle we can write here beta. This and this being parallel. Then sum of this angle and this angle should be 180. 180. Okay. You know the reason. Then this must be 180 minus beta. Right. What is this angle? Here alpha. This is therefore 180 minus alpha. Then we can write T2 on applying Lamy's theorem here. T2 divided by sine angle between the other two forces. T2 divided by sine 180 minus beta. Equals W1 divided by sine what? This angle, no? W1, the angle between other two forces. 180 minus beta plus alpha. Like this. Right. Now you can subject here T2. This one sine alpha. Bring that to right hand side numerator. Here we take this minus sign out. Then 180 minus, within bracket we get beta minus alpha. No? Sine 180 minus, within bracket beta minus alpha means sine beta minus alpha. We get we get sine beta minus alpha. Then here we apply again the Lamy's theorem. This angle 180 minus gamma. T2 over sine 180 minus gamma equals W2 over What is the angle between other two forces? Beta plus sine beta plus gamma. Sine beta plus gamma. Then this is sine gamma T2 W2 into sine gamma divided by sine beta plus gamma. Then this T2 and that T2 you can equate. Therefore, W1 sine alpha upon sine beta minus alpha is equal to W2 sine gamma upon sine beta plus gamma. Bring this W2 here, this here, this here. So we get W1 by W2 is equal to sine gamma times sine beta minus alpha and sine alpha you can bring here into sine beta plus gamma. Thereby, we take this answer. Right now. Right. Next one, a body begins a motion with initial velocity u, moves in a time t with uniform acceleration simple a, acquires that final velocity v traveling a displacement s. Using the velocity time graph of the body, derive the following equations of motion. Right. Right. Now, number 6. VT graph in the row. See here, the axis here, uniform acceleration, initial velocity is u. If you take this angle as theta, tan theta you know, the acceleration. Uniform acceleration, simple a, and takes the velocity v, final velocity v. The time taken is t. The displacement primarily is s. Right. This is the VT graph. Ask him to obtain this equation of motion. Huh? Yeah. You know, this OABC area, you know, OABC area gives us the displacement traveled is. But OABC is a trapezium. Area of a trapezium is half sum of the parallel sides u plus v into this base c. Then we get thereby the answer first term. S equals u plus v divided by 2 times 2. Then other one is tan theta gives the acceleration. Tan theta is the acceleration t. But tan theta we can write opposite side v minus u, adjacent side t. T minus u by t equals a. Okay. Then we get use the cross multiplication, bring this to the right hand side. V equals u plus a. Second one. Third one we can take, put this v value where? Here and simplify it. Now s equals u plus this v we replace by u plus at, right? Divided by 2 times t. Then s equals 2u times t divided by 2. Then ut. Next one, 80 and t, 80 square divided by 2, half 80 square. We get like that. Huh? The next one, fourth one you can take. For this t here, subject t by this and substitute. By v equals u plus at. You can write t, bring this u here, divided by a. Put that in this number one. Now, s equals u plus v by 2 times t means v minus u by a. 2a and this is 2a is here v plus u, v minus u, it is v squared minus u squared. Then v squared equals, bring this side, u squared plus 2a is. We say, we get that now. Right. It's part B. A particle is projected vertically upwards with velocity u meters per second. After time t, another equal particle is projected vertically upwards with the same velocity from the same point. Should that this answer? Should that this answer? Here, first particle, right? Particle 1 projected upwards. Yeah. Then this goes to a maximum height, and while coming downward, the collision must take place because the second particle also projected initially from the same point with the same velocity, right? Then this is the second particle. So also the same velocity, number 2 second particle. Then if the first particle takes capital T time to reach this position, second particle is projected a time simple t later. Then, okay, the time taken by the second particle to reach this collision place is t minus t. Correct, no? Now, suppose in the morning, 10 o'clock this particle is projected. Second particle projected 10 past 5 seconds. Both particles collide at 10 past 10 seconds. Then you can see first particle taken 10 seconds for the collision. Second particle projected 5 seconds later. No? So the time taken for the collision for the second particle is first particle 10, the delayed time 5. Subtracting that, you can take that. But the height to the collision, if I take as h, just before the collision, both particles have the same displacement. Then you can apply s equals ut plus half h squared upwards for 1, particle 1. Height is h. U capital T plus half. All right. G is minus T, no? G T squared. Number 1. Secondly, particle 2, we apply the same thing. H U T minus T minus half G T minus T perfect square. Number 2. By solving this two, we get the capital T answer only asking, take 1 minus 2. 1 minus 2 or 2 minus 1, whichever correct. H and H 0. Here we get ut minus ut will be 0. Then here we get minus u simple t. Now take here minus d by 2 out. Then here we get t minus t perfect square. Correct, no? This minus this means this is plus now, no? 2 minus 1 now we take. Then I'll write it like this. You know, when you take the difference, this minus this will be plus. Then d by 2, I take out a plus sign. Then here we have t square. When you take d by 2 out here we have minus t minus t perfect square, like this. Then simplify this, you get the first answer. Take this ut to this side. D by 2 t square minus t square plus 2 tt minus t square. Then we can cancel down this 2. Right? By solving this, you can find the capital T answer. Another simple T you can cancel down here. T, T, T. You can cancel down. Then subject this capital T answer, you get that. Then what's the answer asking? Yes. Yeah, now subject this, we get this answer. Yeah, then we get there 2u over g. Bring this to here, d here. Then within bracket we get 2t minus t, no? 2 capital T minus t. I mean this side. Divide by 2. 2 by g. 2 by 2 is capital T. Height to the point they meet from the initial point is this much. That means this h we have to find. Put the terms of capital T here and here. Simplify this. Then we get this h. Okay. So I think you can take that answer. This the answer. Put in number 1 for this capital T and simplify. You get this answer. Right. That's the end of the paper number 13. Right. Now, test paper 14, part T. Right. Yeah. Question number 1. Part T. Right. Okay. Right. Question number 1 says the equation of the perpendicular bisectors of the sides AB, AC, right? Suppose this is our ABC triangle. Equations perpendicular bisectors of AB. Perpendicular bisector means the line that passes through the midpoint of the side perpendicular to it. This is the perpendicular bisector. Perpendicular bisector of AB, it's here, minus y minus plus y, no? plus y equals 0. And AC bisector here. This equation, x plus 2y equals 0. And given that point A, 1 minus 2. Then find the equation of the side BC. Equation of side BC asking, huh? Yeah, I'll take this A. I'll take this coordinates of B as alpha beta. Then this is the midpoint of AB, no? Then here the midpoint coordinate, x coordinate is 1 plus alpha by 2. Y coordinate, this plus this beta minus 2 by 2. Now we need to find alpha beta. This midpoint is on this line, therefore the coordinates of this point should satisfy this equation. Right? Then substitute x here, this y here, this. Then we get what? 1 plus alpha by 2 minus beta minus 2 by 2 plus 5 equals 0. Right? Then take one equation involving alpha beta multiplied by 2 alpha minus beta. Here we get 1 minus 2, then 3. And here 10, 13, take to right hand side minus 13, number 1. Correct, no? First we multiply by 2. Then here 10. Here 2 plus 1, 3, 13. Take to right hand side. Other equation we can take, you know, the gradient of this is, right? When subject y, taking this right hand side, x coefficient is the gradient, no? Gradient of this line is 1. Right? Gradient is 1 of this line. Now gradient of this AB, you can find. How to find the gradient? Difference of y coordinate, beta minus 2, beta plus 2, divided by alpha minus 1. Difference of x coordinate is the way of finding gradient. This gradient multiplied by this gradient should be equal to minus 1 because this AB and this perpendicular. Thereby, you can take another equation. This way, this is the multiplication we get 1 minus alpha. Take this side, alpha plus beta. Take this right hand side minus 1. Number 2. Now solve this 1 and 2, you can find alpha beta. When we add 1 and 2, we get alpha, alpha 2 alpha, minus beta plus beta will cancel off, minus 30 minus 1 minus 14, alpha minus 7. When alpha is minus 7, put that minus 7 here, beta. Minus 7, you take right hand side, plus 7, then beta is 6. Then the point B comes as alpha minus 7, beta 6 means point B is minus 7, 6. Okay. Right now, similarly, take the point C as gamma delta. Similarly, take point C as gamma delta. Then using the same technique, take two equations this way involving gamma and delta as we did here. Possible, no? Take this C as gamma delta. Using this and this method, take another two equations involving gamma and delta, solve in them, find gamma and delta. I think you can do that. Then the point C also you know. Okay, gamma delta we know. Both B and C now we know. Then how to find the equation of BC? Equation of BC, now you can find like this. Since we know the coordinates of C and B both, taking the difference of y coordinates dividing by difference of x coordinate, find the gradient of this BC. Then use this y minus y naught equals m times x minus x naught. Use this gradient just now we found. What are these x naught y naught? Any point on the line BC, you can take your x naught y naught as point B of point C. Then you can take the equation of BC. That's the method. I think rest part you can do. Okay, no? Right. Right. Next one, number 2. Find the equation of the normal drawn to the curve given by the parametric equation this. Right now, suppose this is our graph. Suppose the graph, the equation given parametrically. That means x is given in terms of parameter, y was given in terms of parameter. That is the parametric form. T plus 1 squared times t. It's the x coordinate. Its y coordinate at any point given by t cubed by 2 plus 2. Then at the point t equals 2, ask him to find the equation of the perpendicular, no? Normal means perpendicular. Right, this is x-axis, this is y-axis. Right, first of all, we'll find what is this point corresponding to t equals 2. When t equals 2, x, you can write it, put 2 plus 1, 3 squared 9, into 2, 18. Right? X is 18. Right, no? T equals 2 when you put here, 8 by 2 is 4, 4 plus 3 is 7. Y 7. Then the point is 18, 7. Suppose that point is here. At this point, the tangent is this, perpendicular is this. This is the what? This is the one we need to find. Yeah. Then, first of all, we'll find the gradient of this. Gradient of this tangent means dy by dx. Then we have to first take the dy by dx expression. To get the dy by dx, we have differentiate this relative to t. This relative to t. Then we get dx over dt and dy over dt. Thereby, using chain rule, you can find dy by dx. Right? That's the next one you have to do. Right. Now, x is t plus 1 squared into t, no? We'll expand this. T squared and this t cube. Here we get 2t squared, here t. Then dx over dt, 3t squared plus 4t plus 1. And y t cube by 2 plus 3, no? Then what is dy by dt? This 2 is half, no? 3 comes before 3 t squared divided by 2. This is a constant 0. Dy by dx is what? Dy by dt multiplied by dt by dx. Right, no? Then dy by dx is equal to dy by dt is this dt squared by 2 multiplied by dt by dx means the reciprocal of this 1 upon dt squared plus 40 plus 1. Then we need dy by dx where at t equals 2. Where at t equals 2. At t equals 2 only. Now this 18.7 point is corresponding to t2. T equals 2 this point. Huh? So t equals 2 here. And we get here 4, 312 by 2, 6. Here 12, here 8, here 1. This is 21. 6 by 21. 2 by 7. Then the gradient of this tangent is 2 by 7. So what is the gradient of the perpendicular? Take reciprocal of this and multiply by minus 1. Minus 7 by 2. Okay. Now we know the gradient of the normal. Its equation now we need to find. Then use this. M is minus 1 by 2. Your x naught, y naught is this point 18.7. Therefore, the equation of normal. Huh? Equation of the normal. It is y minus y naught is 7. Gradient minus 7 by 2. X minus x naught 18. We simplify this, you get that answer. Right, now the next one, number 3. I take number 3. Number 3 is limit x going to 1 over root 2 cos sine inverse 6, cos sine inverse 6 minus 6, 1 minus cot cos inverse 6. You are given a hint. Cos inverse 6 plus sine inverse 6 equals 5 by 2. Yeah, now, right, I take it like this. I'll take this way the substitution. Let the sine inverse 6 means sine inverse 6 means people certain angle. Let theta equals sine inverse 6. Right? Then this gives us taking the sine inverse this side sine theta equals 6. Right? Now, here the limit x going to 1 over root 2. No? Limit x going to 1 over root 2. That means this is 1 over root 2. Sine theta equals 1 over root 2 means what is theta? Theta is 5 by 4. No? When I put 1 over root 2, sine theta equals 1 over root 2. Sine theta 1 over root 2 means theta is 5 by 4. Then x going to 1 over root 2 means theta going to 5 by 4. That's fine. Now, I'm going to write this in this manner. Limit x going to 1 over root 2, now I can write that as limit theta going to 5 by 4. Here cos sin inverse x. Sin inverse x is theta minus x. X is sin theta. 1 minus this cot we can write as cot means cos by sin. Cot means cos divided by sin. Cos inverse x means cos divided by sin is the cot. Then here we have write cos inverse x. Here we have write cos inverse x. Right? Now you can take limit theta going to pi by 4. Here we can take common denominator as sin cos inverse x. Then this comes here sin cos inverse x minus cos inverse x. So what is cos inverse x? Cos inverse x means 6, right? This is 6. And here we have cos theta minus sin theta. Right. Now we can write limit theta going to pi by 4 cos theta minus sin theta. For this cos inverse x, we can write sin this cos inverse x. We are given people cos inverse x plus sin inverse x as pi by 2. Then what is cos inverse x? Cos inverse x equals pi by 2, take the right hand side, pi by 2 minus sin inverse x. Then I can write here sin cos inverse x pi by 2 minus sin inverse x. For what? For this cos inverse x, I substituted pi by 2 minus sin inverse x. Minus x. X is sin theta. This sin cos inverse x goes to numerator here. Sin, this goes to here. Cos inverse x. This cos inverse x also, again we write pi by 2 minus sin inverse x. Pi by 2 minus sin inverse x. Pi by 2 minus sin inverse x. Okay. People, you know, here sin inverse x is theta. Now you can write because limit theta going to pi by 4 cos theta minus sin theta. Here theta, no? Sin inverse x here theta. This is theta now. Then what do we have? Sin pi by 2 minus theta. It is cos theta. Cos theta. Here, this is theta. Sin pi by 2 minus theta. It is also cos theta minus sin theta. Here. Now these two you can cancel now. Then theta going to pi by 4 cos theta. Substitute for this theta pi by 4. Then we get cos pi by 4. It is 1 over root 2. That's how we get answer. Right. And number 4. Next one, number 4. Find the solutions of the equation sin inverse 5x plus sin inverse 5 root 3x equals 5 by 2. Yes. Sin inverse 5x plus sin inverse 5 root 3x is equal to 5 by 2. You can take this as your alpha, this as your beta, then sin alpha is 5x, sin beta is 5 root 3x. Then the given equation becomes L plus beta equals 5 by 2. Take this beta to right hand side, 5 by 2 minus beta. Then take sin on both sides. Sin alpha equals sin 5 by 2 minus beta. Sin alpha equals cos beta. Now square both sides. Squaring, we get sin squared alpha is equal to cos squared beta. Sin squared alpha means, this means square of this 25 x squared. Cos squared beta means 1 minus sin squared beta. Then 25 x squared, 1 minus sin squared beta means square of this. What is that? 5 squared, 25 root 2 squared is 3. Then we get 75 x squared. When we decide 100 x squared equals 1, x squared 1 over 100, x is plus or minus 1 upon 10. Then this minus answer you can't take. The reason, when you take minus sign, this will be minus. The minus you can take out. Huh? Here also, this will be minus when you take this minus 1 over 10. That minus also we can take out. Then that minus sign we can take out. The left hand side becomes negative angle. But right hand side we have positive angle. Due to that, the minus answer we can't accept. Huh? So therefore, answer is x equals 1 over 10. Number 5 we need fxy given this way 2x squared plus lambda xy plus 3y squared minus 5y minus 2, right? 2x squared lambda xy 3y squared minus 5y minus 2. Asking to write in the form ax plus dy plus c times dx plus qy plus r. How to find lambda abc? There are 7 unknowns you have to find. We can find first, put x0 both sides. Then this is 0. This is dy squared minus 5y minus 2. 0 brings us dy plus c, qy plus r. You can factorize this. Factorize this. You can factorize here dy, ay. Here you can put minus 2 here plus 1. No? Then we get 3y squared. Here we get 6y plus y is minus 5y minus 6y plus or minus 5y minus 2. Then directly we compare both sides. Directly we compare both sides. Right now, when we compare, this 3 is B, this 1 is C, here 1 Q, here minus 2 R. You can write B equals 3, C equals 1, Q equals 1, R equals minus 2. Okay. Now, 4 unknowns we have. Right. Now, put y equals 0. They are here. When you put y equals 0, there we get 2x squared. This is 0, this is 0, this is 0 minus 2. Right hand side. Y0 means first bracket x plus 3, second bracket c plus r. Right. We know this value of c. Substitute for c 1, c we don't know, r minus 2. Left hand side we have 2x squared minus 2. Then here, as we did here, no longer we equate the left and right. We compare left and right. No longer we do the second location. Second location we have to equate the coefficient. Right. When you multiply this and this, we get x squared term. Coefficient is AP or PE. That should be equal to this 2. Number 1. And we take the x coefficient on the right and left. This and this minus 2a. This and this p. But left hand side, you can see we don't have x term, the coefficient is 0. Therefore, p is 2a. Number 2 relation. By this 1 and 2, you have to find this p and me. Put that, but p is here. P2, by 1 and 2. P is 2a and a product. Yes. P is 2a, put here 2a. 2a squared is 2. Then a squared is 1 by cancelling this. A will be 2 answers, plus or minus 1. If A is having 2 answers, for P also we can get 2 answers, right? A equals 1, what is P? Put here 1, 2. A equals minus 1, P is minus 2. Then for this B, C, Q, R, for each 1 value. But for this A and P, each 2 values, right? Right. Now then 2 sets of values come in. But now we have to find lambda. Lambda can be found very easily like this. Right, in this as star. In this left and right, this xy term, coefficient is lambda. Left and right, we equate coefficient of xy product. Coefficient of xy product. Right. Equating coefficient of XY product. Left hand side it is lambda. Right hand side, how do you get people XY product? By this X term, when you multiply the second bracket Y term, we get XY product term coefficient A Q or QA. And when you multiply this and this, P V. Right. We found lambda. Now, there we can take first when A equals 1, B equals 2, one value for lambda we can find that Q is 1 also 1, put 1 here for Q, A also 1, and P 2, B they are 3. Subject this, lambda is 7. Second answer for lambda can be obtained taking the second set of A and P. A minus 1, P minus 2. Right? Now, lambda. Here Q 1, A minus 1 plus P minus 2, B 3. Then here we get minus 6, minus 1, minus 7. Right. So therefore, lambda has 2 answers. AP each has 2 answers, but this have each for 1. This is how we find them. Huh? Right. That's the end of that Q part. Okay. I will come to the number 6. Applied part. Huh? Yes. A smooth ball B of mass simple M is M is on a smooth horizontal plane at a distance simple D. D at a distance simple D. Away from a smooth vertical ball, another smooth identical ball A moving on the same plane towards the wall collides directly on B, and then B strikes on the wall. So then first impact we can write between A and B. Okay. I will take the velocity of A moving as U. Right. First impact between A and B. Right. We can apply this, you know, A moving with U, but B is at rest. Then after that, both A and B move. With velocity V1 and V2. We can apply conservation of the momentum rightward. Mass of each will take as M because we are given identical mass, identical particles. Then MV1, MV2, the momentum of impact is equal to MU. MU can cancel down. V1 plus V2 equals U number 1. Now we can apply Newton's law of restitution rightward. It is what? Minus E times relative velocity before impact, before V is at rest, Then u is the relative velocity of A relative to B. After impact also, you have to stop this B. Also stop this B, apply this B to leftward, the same B to leftward, right? On this A. Then this will be at rest. Now A has rightward V1, leftward V2, then the rightward direction velocity of this A going to be V1 minus V2. Number 2. Now by 1 and 2, we can find V1 and V2. V1, you will get U by 2, 1 minus V. V2, you get U by 2, 1 plus V. This is how we get. Then soon after impact, this A and B move this way. Right. B begins to move. This velocity V2. A begins to move towards the same direction. This velocity V1. Okay. Then you can see this B has to move displacement D to make the collision with the wall. For this, it takes certain time, right? That time is nothing but D displacement with velocity V2. Time is displacement divided by velocity. With the time taken, V to reach the wall is, if I take as T1, what is that T1? T1 is what? T divided by V2. Okay. Then we come to the wall. During that time interval, A moves forward. What is the distance this A moves forward during that time interval? Initially, A is here. During a time interval E1, A moves forward with velocity what? V1. What is the distance it can move? Displacement is velocity multiplied by time. No? It's equal to T1. Then the time is T1, velocity of A is V1, then this distance is V1 T1. Right? Now at the moment this B strikes on the wall, the distance between A and B, here now place of A and B is this distance. What is that? Initially D, now A moved towards the wall this much. Therefore, this length is going to be D minus V1 T1. Right. Now what happens? Soon after going to the wall, the particle B, what? Strikes the wall and rebound. So this B goes to the wall with velocity V2, and you know it rebounds from the wall with the velocity E times V2, with the velocity E times V2. E times V2, this way. E V2 velocity, that rebound. That we know in the lesson, we learned that. What are the things we learned there? When a certain particle strikes on a fixed plane with velocity U, it rebounds with EU. E means the coefficient of substitution between the wall and the particle. Therefore, that rebounds EV2. Now, you can see another second impact takes place. B comes in the written motion. A is still going towards the wall. Then in between these 2 points, another impact takes place. Then I'm going to take that position like this. Somewhere here and here. No? Then I take, this is B, move in this direction, A, move in this direction. Then this length and this length, when I take S1 and S2, then S1 plus S2 should be equal this length, no? Why? When we rebound from the wall, A is at a distance from the wall this much. Then A goes towards the wall, B comes towards A. Therefore, the displacement traveled by A and B should be equal to this length. Okay. Then I am going to first find soon after rebounding this B from the wall, the time for the second collision between A and B. Then that time, if I take as T2, what is T2? The time for the second collision between A and B soon after rebounding B from the wall. T2, when I take that time as T2, here, this A moves still with V1 velocity towards the wall, but B moves away from the wall, EV2. Then the time is T2, then A moves a displacement 1, V1 into T2. That's the displacement solved by A towards the wall. Plus EV2 T2. What? Displacement traveled by B away from the wall. Their sum should be equal to this length, no? This comes towards the wall, this goes towards the sum is this B minus V1 T1. B minus V1 T1. Now, by this, we have to find T2. We'll find T2 how? T2 V1 plus EV2 divided V1 T1. Then T2 you can write T minus V1 T1 divided by V1 EV2. Now, what is people asking there? The asking thing is this. For the point of the second collision, the distance from the wall, this is asking. This is the point where the second collision takes place. So that position, the distance from the wall. What is that? During the time interval T2, the displacement traveled by the particle B away from the wall. It is what? It is now moving with EV2 velocity, no? EV2 into T2, no? And displacement S2 is equal to velocity into time. Right. Then EV2 is the velocity of V times T2. Then the S2 is the asking answer. S2 is EV2 into T2. Now we have substitute for this T2 here and keep simplifying. You get this answer. All right, we'll do the simplification. S2 EV2 T2. T2 is this. B minus V1 T1 divided by V1 plus EV2. Right? Now, we can substitute for this T1. EV2 T minus V1. T1 means D over V2. And here V1 plus EV2. Right. Now, people, we will bring this V2 inside. We will bring this V2 inside. Right. I erase this now. S2 equals V times dV2. Once we bring this V2 inside, that V2 and this V2 we can consider down dV1. Divided by V1 plus dV2. Now, take this B out. dE within brackets V2 minus V1 here V1 plus EV2. Now substitute for this V2 minus V1 by this answer. V2 minus V1 means EU. right? It's 2 TU. V1 and V2 now we have substitute. V1 U by 2 times 1 minus E plus E times V2 U by 2 1 plus C. Now this U you can cancel down. Then this 2 we can bring numerator 2D E squared coming here 1 minus C plus E times E plus E squared, no? Minus C plus E you can cancel down. This 2 comes as 2D E squared divided by 1 plus E squared, no? This is how we take it down. Okay. Right. Now soon. A particle is projected from point O with an angle theta. Velocity 30. This way it passes the point of height 10 meters and distance from here or 40. Yeah. Put S equals UT. Right. 40 equals 30 cos theta into T. This and this you can cancel down. Right, no? S equals UT, no? Then T is 4 divided by 3 cos theta. Right. Now we can write S equals UT plus half A to square this way. Then to sine theta. That means 30 sine theta. 30 sine theta. P is answer 4 over 3 cos theta plus half A minus G. G is 10 minus 10. T squared 16 over 9 cos square theta. Right? Then this 10, this 10, this 10 you can cancel out. This 3 and this 3 also you can cancel down. Then just cancel, we have 1 equals 4 tan theta if this and this we can cancel down 8 by 9 minus 1 over cos square theta means sec square theta, correct, no? 1 over cos square theta is sec square theta. Sec square theta is 1 plus tan square theta. Correct, no? 1 over cos square theta is sec square theta. Sec square theta is 1 plus tan square theta. Now, while multiplying by 9, bring all the terms left hand side. When you multiply this by 9, you get minus 8 here. Minus 8 tan square theta, when you take this side, 8 tan square theta. When you multiply this by 9, 36 tan theta minus 36 tan theta. When you multiply this by 9, here we get minus 8 into 1 means minus 8, take this side, plus 8, with this one plus 9. 0. Count. What is that? We have multiplied this by 9, no? then that 9 is there, right? And there, when you bring minus 8 is 5 plus 8, 9 plus 8 is 70, not 9. 70. This should be multiplied by 9, no? Both sides be multiplied by 9, no? That's right. Now, show that there exist two angles of projection and find these angles. If these angles are theta 1 and theta 2, show for that this now. Now, this is a quadratic equation in tan theta. You have to prove there are two angles. If there are two angles, there should be two values for tan theta. Yeah, we'll find delta of this. V square minus 36 of x square minus 4a is 8, 17. Okay. Here you can see 36 of x square is 1000 something we get, no? This is really what 32 into 17 means less than 1000. Therefore, this delta is positive. Therefore, this equation has two real roots. That means for tan theta, there are two answers. When there are two answers for tan theta, there should be two angles for theta. Right? Thereby, you can say that answer. Then, therefore, there are two distinct real roots. For this equation. There are two distinct real roots for this equation. Two distinct real roots for this equation. There are two answers for tan theta. When there are two answers for tan theta, there are two angles, theta 1 and theta 2. Hence, there exists two values for theta. Hence, there exists two values. There exists two values for theta. But in the question we are given, those angles are theta 1 and theta 2. If those angles are theta 1 and theta 2, then what are the roots of this? Tan theta 1 and tan theta 2. Okay. Then, if the roots of this equation are tan theta 1 and tan theta 2, sum of the roots, you know, in quadratic equation we done minus b divided by a, 36 divided by 8. See, cancelling 9 by 2. Product of the root, tan theta 1, tan theta 2. Product of root, c by a, 17 by 8. Now what is asking? Tan theta plus tan theta 1 plus theta 2. This one. We don't like tan a plus b. That expansion you can do. But tan theta 1 plus tan theta 2 divided by 1 minus tan theta 1, tan theta 2. Right. Substitute this 9 by 2 here, 17 by 8 here, simplify this, then you get this answer minus 4. Answer minus 4 come in like that. Huh? Right. Number 8 is the work power energy part. Right. Given this way, a cow's mass 2000 kilograms, right? This is the cow, 2000. It pulls the caravan of what 400 kilograms along a horizontal track. The resistance on car and caravan car 1000 newtons, and caravan 100 newtons, right? In the tow bar, tow rope, tension T suppose. When the car and caravan both move with velocity 40 kilometers per hour, 40 kilometers we can convert to meters per second, multiply this by 5 and divide by 80, no? Huh? Correct, no? 40 kilometers per hour, viewer, no? 40 kilometers per hour. Okay. Then 40 kilometers per hour we can convert to meters per second, multiplying it by 5 by 80, no? You know this, right? Correct, no? Then there you get the here 9, here 20, 100 by 9. Velocity. M is minus 1. Correct, no? Yes. With the power of the car, 100 kilowatt. Power of the car, 100 kilowatt. You know, H equals FP. Then reactive force H equals H upon V. 100 kilowatt means 100 into 10 to the power 3 watts. Velocity is 100 by 9. This is the reactive force. Here. 100 into 10 to the power 3 divided by 100 by 9. Find the acceleration. Yeah. Acceleration we can write. How? For the system, we apply F equals MA right road. System means car and the caravan both. When you take the fall thing, this speed will cancel out. Total force forward, this 100 into 10 power 3 divided by 100 by 9 minus 1100. Total resistance force. Right. I is equal to total mass 2400 into acceleration is 8. 2 zeros we can cancel down. Here 1000, here 100, then 100, then this here 90 minus 11 divided by 24 equals 6 equals 79 upon 24 m is minus 1. At this moment, find the tension in the rope, tow rope. For the caravan, now apply F equals MA. For the caravan, we apply F equals MA rightward. T minus 100 is the form. Mass is 400. Acceleration is A, just now we found 79 divided by 24. T is equal to 400 79 divided by 24 plus 100. Simplify this, huh? Right. Number 9. Number 9, two particles A and B, each of mass simple limb jointed by a light initial string passing over a smooth pulley fixed at the top of a smooth inclined plane of inclination 30 degrees to the horizontal, as shown in the diagram. Particle A is on the plane and particle B hangs. The system is released from rest. Find the velocity of the particles when A has moved the distance, simple L on the plane. See, right. Now, mass is M of each. Here A, here B. Right? Particle A is on the plane and particle B hangs. The system is released from rest. The plane is smooth one. Find the velocity of the particles when A has moved the distance simple L. So what sense this will move people? This is certain, no? Right. When this direction mg sin 30, mg by 2. But here this direction mg. This side is heavier. Then this part is moving down, this is moving up. But now I will take initially the height for this one. I take h1. This is h2. Right. When this particle A moves on the plane, the displacement is the L. Right. Suppose this height as capital H1. So once this A moves on the plane of 1 meter, L meters, this moves down what? Another L meter. Let us take this as capital H2. Now you can take the potential energy zero level here. Right. Once this particle A reaches this position, suppose its velocity is v, then the other end, the particle v also having the same velocity v. You agree with me? Then in this case, you can apply conservation of mechanical energy. Understand? Conservation of mechanical energy. Right? Here, at the beginning, both were at rest, no kinetic energy. What is the potential energy? mg h1, right? Here plus mg h2. The total potential energy, both were at rest, no kinetic energy, equal to here and here kinetic energy, half mv squared plus half mv squared. Then multiply this by 2. Okay. Why? There are two particles, no? Total kinetic energy is that. Next one. Plus, yeah. When this particle reach this position, the what kinetic energy we wrote and potential energy we need. What are that? mg h1 plus equal here mg here H2. Right. Now here, this and this you can cancel down. Mu squared, Mg, this H1. H1 means this height from here to here, no? It is simple H1 plus this height. When this is 30, this is L, this is L sine 30, no? L by 2. And Mg H2. This is H2. Right? All height is H2. Descended L. Then this H2 means simple H2 minus L. This is. Yeah. Then here we have MgH1, MgH2. Here we have MgH1 that you can cancel down with this. Here we have MgH2 that you can cancel down with this. Then M you can cancel down. Left hand side we have 0. Here B squared. GL by 2 and here minus GL. Then we get B squared GL by 2. B is the root of B. Correct, no? This is how we did it. Okay, number 10. A smooth hemispherical ball of radius simple A is fixed such that its circular rim is horizontal and uppermost. A uniform rod of length 2A rests with one end in contact inner surface of the ball and a point of the rod in contact the rim of the ball. Find the length of the rod beyond the rim of the ball. Beyond the rim of the ball. Right. But a similar question I think we have done in our theory classes. Right. Shall I erase this now? Right. Now, this is that. Right. Go like this. Into here. This also, right. Right. One end inside the ball like this of the rod. Right now, the reaction coming here. That reaction passes to the center. Right. So this is it. Here reaction will be perpendicular to the rod here. Here reaction by the edge or the rim of the ball perpendicular to the rod. Therefore, that reaction should pass through point this. You know the reason for this. Right? Then this is suppose R. They meet here. Then the next force is the weight of the rod. Finally, rod is in equilibrium, subject to the action of three forces. The three forces must meet. Therefore, the line of action of the weight of the rod, when you produce, that should pass through the point this. This is force diagram. It's a uniform rod. Therefore, center of gravity acts at the midpoint. Here the midpoint, this and this being equal. Suppose this rod is, right? Take A, B, then B, C. Length of rod is 2A, therefore this is A. The radius of the board is simple A, diameter 2A. Then when we draw here horizontal line, people, that line should definitely pass through point this. This way. That's the geometry. Why? This is a diameter. Okay. This is vertical line. This is horizontal line. You know, vertical line and horizontal line, when they meet at the point of crossing of the two lines, the angle should be 90. Then this line and this line meet at 90. But since this is a diameter, this meeting point should be on the circle. You know, the geometry here, any diameter of a circle subtends 90 degrees at any point on the circumference. That is geometry. That's the reason. Then this is horizontal, this and this being parallel. If you take this angle as theta, since this and this being parallel, this is also theta. Okay? You know, this length is a radius. The length from here to here also radius. This is a radius, this is a radius. Therefore, this angle and this angle must be equal. Okay. Then you can write this length in two ways. One is, this is A, this is theta, therefore this length is A cos theta. The same length you can write AA, 2A, this is 2 theta, 2A, this is 2 theta, then this length is 2A cos 2 theta. And this way we can geometrical relation we can obtain. Geometrical relation you can obtain. Now using this, you can find theta. How? 2A or A cos theta is equal to 2A cos 2 theta. A and A you can cancel down. A cos theta 2 times cos 2 theta is 2 cos square theta minus 1. Then there we get 4 cos square theta, remove the bracket, take this right hand side minus cos theta minus 2 equals 0. Then you can take two answers for this cos theta here. Right? Factors you can't factor this. You can take that one. How? Minus b. B is here minus 1. Comes to minus square root of b squared means minus 1 squared This 10 minus 4 times A is 4, C minus 2. Divided by 2 into 4. Then cos theta is equal to here 1 plus or minus. Here we get 32 plus 1 is 33. Divided by 8. You can see people here this minus sign when you take the numerator will be minus. Therefore, this cos theta will be minus. Cos theta become minus means theta should be more than 90 because in the second quadrant only the second quadrant and third quadrant only the cos is negative. So therefore, this theta should be more than 90 if this is the minus sign. But obviously, this theta is acute angle. So therefore, this minus sign you can't take, right? Here we have 8. Right. So then cos theta is what? 1 plus root 33 divided by 8 is a cos theta. Now asking this length people. This length you can write how? VC length. VC length is from here to here 2a because we are given the length of the rod as 2a. From 2a we have subtract this part AC. AC part we have subtract. Then VC equals 2a minus AC. A to here. AC is here. This is 2a. This is theta. Therefore, AC is what? 2a cos theta. 2a cos theta. That cos theta only here we have people. Put that there. VC, bring this 2a out. 1 minus cos theta. 2a times 1 minus cos theta is this. 1 plus root 3 by 8. Correct, no? Then I think, yes, here this 8 coming to the whole thing. No? 8 minus 1 minus root 3 by 8. Then we get 2a 7 minus root 3 by 8. This is the length of the part of the rod hanging beyond the rim. Right? Now this is how we do that part.